In this video, we'll talk about what is really the sort of total first derivative of a function of several variables. Remember, in the sections on partial derivatives, we could only really differentiate one variable at a time. Well, here we're going to do all of them at once. But what's going to happen on account of that is we don't really get a regular scalar valued function. We're going to get a vector, right? And this thing is called the gradient. So if f is a function, let's start with two variables here. F is a function of x and y. Then the gradient of f is, well, it's this certain vector. We're going to call it, this is said a few different ways. Sometimes it's said nabla f. I usually say del f. There's all sorts of terminology for it, but we'll stick with del f. So let's call this del here. All right, and what this is we're going to take all of those first partial derivatives and combine them together in one vector. So here we get f sub x, f sub y. Okay? And, well, you could ask, what if we have more than two variables? So if f is a function of three variables, then what we get is del f is fx, fy, fz. Right? And if you have four variables or five variables or so on, you just write out all of the derivatives. All right? That's pretty much all there is to finding the gradient. So let's do an example of that. So example. Find the gradient of, let's say, f of xyz is x e to the xyz. Right? Okay, so to solve this, or to compute this gradient, del f here, I think sometimes I might also say grad f, but these are all meant to be the same thing. Actually, that reminds me, sometimes, and I think this is pretty common in physics if I'm not mistaken, it's pretty common to actually see this written as grad f, not just del f or something like that. Anyway, so to compute this guy, all we have to do is find the derivatives. So to compute the derivative of this, the partial derivative with respect to x, well, this is just going to be a product rule and then a chain rule. So the first function is x, the second is this e stuff. So derivative of x with respect to x is, of course, 1. So we just have e to the xyz. And then we have to take the derivative of this, or keep the first, take derivative of the second. Derivative of the second, we're going to get a yz that comes out front. So we get plus xyz e to the xyz. Right? And that's the derivative of this with respect to x. And now we do it with respect to y and then z. And then we see the y derivative is going to give us x squared z e to the xyz. And the z derivative will give us x squared y e to the xyz. All right? And that's pretty much it for the gradient. To actually find the gradient, there's going to be tons and tons and tons of things we can do with the gradient. But as far as just writing it down as a vector, that's pretty much all there is to it. And we'll learn later, this is actually more generally what's called a vector field. It's the gradient vector field of a function. But we'll get to that when the time comes.